So in this video, I'm going to show you how to create a more realistic model of the cooler in ICEM. So what I'm trying to create is such a geometry. This is a side view. We have this foam layer. Okay. And then we have an aluminum container without lid. So suppose it looks like this. So here I assume that the container is in direct contact with the foam, so there's no any gap in between the container and the foam. Of course, the real situation probably is not so ideal. I mean, even the container and the foam do contact each other directly. Usually the contaction is not perfect. There are, small areas, spots that are not in direct contact, right? There is some air in such regions. I mean, no matter the last year's prototype cooler or the cooler we are trying to build this year, most likely we really want this inner container to be in direct contact with the foam, because that will reduce the shaking of the container, right? So here I will simply assume that this is the case. The aluminum container is in direct contact with the foam. And in last year's experiment, they used one bag of liquid water to simulate the lung tissue. And if my memory is correct, it was 5 liters of water in the bag. Okay, so but I'm not 100% sure. So you probably want to check their final report and to find out how much water was used in the experiment. So here I will assume here we have a certain amount of water, okay, which fills the lower portion of the container. So this is water. Okay, it's not just water, okay, it's water in the bag, in the plastic bag. Okay, so don't worry about the bag thing right now, okay? The bag is very thin, and we probably don't even want to produce a separate geometry for that very thin bag. Okay, we will have a different way to handle that bag geometry. So basically here we have this foam, okay, and we have of course this part is air, right, and this part is aluminum, and this part is water, but of course water is inside a bag. So this is a side view. The top view will be something like this. Okay, we have this foam container. Okay, if we open the lid of this foam container, what you see is something like this, right? You have this aluminum container which is in direct contact with the foam. So This is aluminum. Okay. Then at the bottom, you see a water bag there, right? And this is the water. So the water bag is assumed to again spread over the whole bottom surface of the container and have direct contact with the container surface. Okay. Of course, this is again not the real situation, but I think we are just trying to simulate the situation as close to the situation as possible. I mean, as close to the real situation as possible. Probably still not really possible to get the real situation, because I mean, that's quite impossible. Here I also do not try to create this geometry in the real scale, because I do not really know the real scale. Okay, so it's your responsibility to find out the real dimensions of all those geometries involved. So here I will only create a geometry with some, dimensions I randomly select. Okay, so in ICEM, say ICEM, okay, I have already had that thing. I will delete everything. Okay, I should be able to delete that. Okay, for some reason I cannot. Okay. What is this? Okay, I believe it's a surface. Why I cannot delete it? Okay, that's fine. But it's quite weird. Okay, I do not quite understand why I cannot delete this thing, so let me first close this project, then get a new project. Okay, first I create this foam part, or the outer surface. So I'm going to create such a big box. Apply. Okay, so now I have that box. Okay. It's not necessarily all the foam, because foam is only part of this geometry, but that's fine. Yeah. The second geometry is I believe the this hollow chamber, right, inside the foam. So let's say it's 0.6, 0.6, and 0.6. So you have to move the origin of this box to 0.2. Okay, 0.2, 0.2, and 0.2. Okay, now I have two such surfaces. I probably want. Okay. So basically, I'm going to use the space in between these two boxes as a foam area. So I will need to create another gap, okay, in order to use it as my aluminum thing. Let me see how to do that. Suppose the aluminum thickness is pretty small, say 0.1, then the size of this box will be 0.5, 0.5, 0.5. So 0.5, 0.5, 0.5. Probably it should be even smaller because the aluminum container is really thin. Okay, so here the origin now should be, I don't know, 0.6, 0.5, 0.1, 0.05, 0.05, 0, no, not 0.05. It should be 0.2 minus 0.05, so 0.15, 0.15, 0.15. Okay, let's see how it works. Oh, it doesn't work. So some calculation problem, right? Here's 0.6, then I move to 0.5. Oh, okay, it should be 0.2 plus 0.05, so 0.25. Okay, 0.25, 0.25. Now this time should be correct. Okay. So what happens is that I am going to use the space in between the second box and this third box as my aluminum container, but there is one small problem because our container does not have a lid, so I do not have this part right in my for my container. Okay, I told Tyler something about how to create more geometries here. I can show you how to do that. Basically, we will need to create some extra surfaces to cover, to represent the top surface of the container. You see here, okay? So we do not have a lid, right? So you have to create those surfaces. Okay, I won't make it bigger. This surface, see here, container. Okay, those surfaces are needed. So what I'm going to do is I will first split the surface of this the second block. The second box. So this is done by using this tool. Okay, segment trim surface. Here by default, the method used to segment a surface is by curve, but here I'm going to select by plane. Yeah, because I don't have a curve to split the surface. So the surface I'm going to segment is this one, and okay, I will select this one. I will also select this one, so I press F9K so that I can rotate my geometry. Okay, then I will select this surface and also this surface. So basically all the 4 vertical surfaces of the second box. Okay, then I press the middle button. Then it asks you to select a point, okay, so that it can create a surface, a plane, and using that plane to cut the 4 vertical surfaces of the second box. So I'm going to choose this point. Okay, this vertex of the smallest box. Okay, it will automatically create such a plane for me, a cutting plane. You can see you can select the normal of this plane. Right now, by default, the normal is in the y direction. So 0 is the x direction, so it's not in x direction. 1 is in y direction, so it tells you that the normal is in y direction. It's not in z direction. So it creates such a plane. Okay, then I press the middle button. Okay, it's done. Okay, all the 4 surfaces of the second box are segmented into 2 surfaces now. Okay, if you do not believe me, I guess you believe me. But if you do not believe me, I can show you. I don't know how to show that. For example, if I delete a surface, right? You can see right now I can select this small surface now because this is part of the surfaces created by splitting the original surface. Okay, so of course I'm not going to delete that surface. Instead, I will create some more surfaces which corresponds to the upper surface or the top surface of the lid. Okay, you probably notice that I have all the surfaces of the aluminum container right now except for those top surfaces. Okay, it has side surfaces, which, for example, this one, not this one, this one, right? This is the side surface of the aluminum. It also has the bottom surface of aluminum box, which is here, right? This guy. So it has the side surface, the bottom surface, but it does not have the top surface. That's why I'm going to create some surfaces for it. So I use this create modify surfaces. Use the first tool. The default method to form a surface is forming a surface from 2 to 4 curves. Here I will choose a different method. Okay, I will form a surface from 4 points. I think that's probably easiest way to do that, to form a surface. Okay, say this point, this point, this point, this point. I used a clockwise order. I don't know if this is the best practice, but I will try to be consistent. Okay, so the first surface is formed, then 1, 2, 3, 4. The second one, again I use a clockwise order. Okay, I should use this one first, right? This one, this one, this one, this one. So the surface, then this one, this one, this one, this one, 4th surface. Okay. Now I have all the top surfaces of my aluminum container. Okay, eventually, is that really necessary? I mean, probably. Who knows? Okay. Yeah. Okay. Then what else? I will need to create this water region, right? Okay, and let me think how to do that. Um, water region. Do I need to create a separate box? Or should I split this surface again? Probably split the surface. Okay, if I split the surface, yeah, that's probably a good idea. So I will first do some interesting thing. I will first split this curve, okay, of the smallest box. See here I have a curve, right? So to create a point, okay, so go to create point. Then this is done by this tool, parameter along a curve. If you use 0.5, then a point will be created at the middle point along a curve. So I'm going to use not 0.5. Suppose it's 0.4. Okay. Okay. Then turn on points. See where it is. Oh, yeah, it's good. Okay. It's pretty. It's closer to the bottom than the top, right? That is good. I will do the same thing for that curve. Then this guy, I believe. And is that this one? Yeah, that's right, this one. But it seems that these two are not correct. So this is the tricky part. Okay, sometimes it's 0.4. Okay, which means you create a point at 40% of the length of the curve. But that really depends on how you define the starting point and ending point of your curve, right? So somehow these two curves, they have opposite directions. So you will have to use 0.6 for this one and this one. Okay. So I will not need these 2 points. Okay, now all these points okay, are located at the same y level, which is, I don't know how high is that, but you can measure it. The y coordinate is 0.45. This one is also 0.45. This one is also 0.45, and this one is also 0.45. Okay, so it's perfect. Okay. What else? I will need a surface, right, for the water. You can see the water right now. In fact, I need more surfaces. Okay, I need a surface here. So I will do the splitting again. Split the surface. So I'm going to split this surface. Is that correct? Yes. Then this surface. Yes. And okay, make sure you select the correct surface. Okay, this surface, and okay, all the 4 vertical surfaces of the inner box. Okay, the innermost box, the third box. So this guy, I believe. Okay, great. Then a point. Okay, one of those 4 points we just created. Okay, great. Great. Okay, so now I have the 4 vertical surfaces of the water, right? these four surfaces, this one, you know. I also have the bottom surface, which is identical to the bottom surface of the third box, but I also need a surface which corresponds to the top of the water, so I'm going to create that surface. Do I need that? Okay, let me think. Yes, because there is the plastic bag boundary, right? So I create such a surface from 4 points. Okay, 1, 2, 3, and 4. Okay, although you probably do not see that very clearly. In fact, when I select the points, the point is highlighted. Okay, now see, a new surface is formed. Okay, at this point, it's probably a really good idea to create more parts, right? So that you can apply different boundary conditions for different surfaces. So first I create a part called face. Okay, face foam top. You know which face I'm talking about, right? This guy. Okay. Then face foam side. That way I'll include this one, F9, turn it, this one, and turn it again, F9, this one. Okay, there's 4 vertical surfaces. Then form face foam bottom, this surface, right? Okay, then okay, what else? Okay, so here we have a few surfaces. Okay, I get it. Okay, for example, here I will change the name of the faces. Okay, it becomes face interface of foam and air. Yeah, I do not really need to give any real boundary conditions at such an interface, so I do not need to differentiate, say, the top surface, side surface, those things. So I will directly select those interface between the foam and air, which is this guy, the top, this side surface, I believe. Okay, and this one, and this one, I believe. No, this one. Okay, let's double check. Okay, this one. Yeah, I think that's correct. So these 5 surfaces are the interface between foam and air. We also have interface between foam and aluminum, right? Aluminum. Okay. Which should be this guy. And okay, I'm going to rotate it. Okay, well, this thing really is like a very, well, it's not so terrible. Yeah, it's terrible. It looks like a terrible video game, but probably it's not that terrible. In my opinion, the Minecraft also has so many, blocks, but interestingly, many people like that. And this one, right? Okay, so yep, that is the interface between foam and aluminum container. Do you agree with me? Okay, then I have the interface between aluminum and air. So phase inter air and aluminum. Okay, that's a lot. Okay, which are the top surfaces of the aluminum and also the inner surfaces of the aluminum, right? Or the upper part. Okay, like this guy. Remember, you are selecting surfaces. Okay, you can turn off the display of curves. And then, okay, let me see. Yeah, this guy and I believe this guy. Is that correct? Okay. And this guy. So these four surfaces are shared by both aluminum and air. I believe that's correct, right? Okay. Okay. Then I have the interface between aluminum and water. Gosh, that's really complicated. Okay, this one, that one, and this one. Okay, oh, and this one, right? This one is also. Okay, very nice. Very good. I think it's very good. Okay, so I select that. Then I also have an interface between air and water. Water, air. Okay, which is this guy. Okay. Now notice that here in fact we have an extra surface here. I do not really need that surface, okay, because it's kind of an interface between air and air. So you do not need that because it's not really an interface, so I delete that surface. This guy here. Okay, just make sure that you select the correct surface. Okay, I think it's correct. Okay, I delete it. That's it. Okay, now I have all the surfaces I need.